Mm. Okay, cool. Thank you, Will. So I want to pull out a few key words that you said in there as you were answering this first question of the warm-up. You mentioned variable assignment. So I just want to like say this again, because I think that this falls in the realm of variable and assignment might have been words that you used before you started Turing, but now they're taking on somewhat of a new meaning. So just to help us practice like talking in like programmer lingo about these things, what's happening on line 12, and Will did a great job explaining this, is that we are creating an array of strings. So this array has 3 strings in it, and we're assigning it with this assignment operator. We're assigning it to the variable characters. So when we talk about what's happening on line 12, I sometimes think of it as happening from right to left. So we are creating an array and assigning it to the variable characters. Now it's a little opposite of like how we typically read English, but that's the way that I think of it in my head. And that's the way that you'll hear folks talk about this idea of assigning variables. Excellent. All right. And then can I hear from these next 2 questions of like what issues might crop up and is there an alternative? This might have been a little bit more challenging to answer. So I'm going to ask for a volunteer. Who would like to volunteer to tell the group what they thought about or wrote down for the issues? Let's go with Olivia.
Hi, I thought about if you had a lot of characters in the array, it would print out a really long output of everything.
Yeah.
So I thought the alternative approach could be like puts characters and then the brackets 0.2.
Oh yeah, so you might print more than one of these strings, which are friends characters, at a time. Yep, totally. Let's hear, I think Chris, you also had your hand up for that.
Yeah, if in that array there was 100 elements of strings and we continued to put each for an index, that would just be a huge issue. So there's easier ways to do it that could scale up. So
cool.
You could well, maybe I'll save that for.
When you talk about a huge issue, can you say more about like what the issue is?
That we're only for the lines 13 to 15, we're only calling for the single index. So if we had like 100 elements in that array, you'd still only get Phoebe, Rachel, Joey instead of the 97 other ones. So it doesn't work for that.
Could I do this puts characters 97 more times?
Yes.
Yes. What's the issue with that?
It's too long. I mean, it's just.
It's a lot of typing. It's a lot of typing. And then like the next issue, actually, before I say the next thing, I think who else had their hand up as part of this? Jenny. Jenny, what did you have for the second piece?
So another issue I could see is you're kind of right now forcing what indexes in the array you're doing. And so right now, if you put 3, it would still run, but it would return null. So even though nothing's in the array, it would still return something, a null value.
Yeah, you're like hard coding exactly what you want. And if there was something in that 3rd index, you get it. But since there's nothing right now, you're going to get nil. Great. Cool. Let's go to this last question. Is there an alternative to doing this like putsing? Who wants to talk about the alternative to this? Did anyone have an idea? Yeah, Doug.
You could use a .each essentially. You would just say characters .each, run this, and then that wouldn't 99, 100, 10,000. No matter how many you have, you would just run the exact number of puts for your array.
Cool, great. I love it. It's really good context clues to think we have a problem. What is the solution to that problem? It's going to be the topic of the lesson that we're going over. Awesome. Cool. So yeah, just to sort of like reiterate the sort of issues that are happening here. And And Chris and Jenny did a great job of walking us through this. And who was the first person to speak? I know there was someone else. Oh, I'm so sorry, I've forgotten who it was, but the three of you did a great job. Yeah, Olivia. So the issues here is that this is what I would consider to be fairly brittle code, meaning it's not very flexible. So we've got some issues of scalability. So like this solution to printing a list of names is not scalable. And what I mean by scalable in this sense is, let's see, what I mean by scalable here is, what do I mean by scalable? Scalable. Easy for a small number of things, hard for a large number of things. So it's easy for me to type out 3 lines of puts character 0, character 1, character 2. It would be hard if I had 100 characters and I was using this puts version, and it would be really, really hard if I had 1,000,000 characters. So when we think about scalability, we want a solution that works just as well for 3 things as it does for 3 million things. Okay. Doug, did you have a question, or is that hand up from before? I'm gonna lower your hand then. Awesome. All right, questions about this idea of scalability, or questions about why this is an issue? As programmers, we often want to like type the fewest number of characters possible. And if we had 1,000 characters, the fewest number of like keystrokes as possible. And if this list of characters had 1,000 people in it, it would not be very easy or efficient to type all that. There's a better way. All right, cool. So let's talk about each. I'm going to make a, let's see, let's just do like, I'm just going to call this the definition of each. So I think it was maybe Doug who started to talk about the syntax of this, but we're going to get into the, actually, that's what I'm going to say, syntax. This is all about each. All right, cool. I want to make sure we hit on a couple of these vocabulary words first, though. So when we're talking about programming in any language, we are going to have an idea of some collection, some like group of things, whether it's strings, integers, something. We might have, not might, in all languages, we're going to have this idea of collections. Do you all know what some of the collections in Ruby are? Or does anyone have an educated guess of what a collection in Ruby might be? Yeah, Adam.
An array or a hash.
Cool, yeah, an array or hash. I think we'll stick with those for now. Arrays and hashes are both collections in Ruby. These are basically just like lists of things. And if it's an array, it's one type of list. If it's a hash, it's a different type of list. But it's a list or a collection of things. Don't you like it when people use the word that they're trying to define in the definition? It's very helpful. So a collection is just a group of things in Ruby. Most collections are either arrays or hashes. There are some other types of collections. We're not going to really get into them, at least in the first few weeks of Mod 1. And really, we're going to start by thinking about collections as arrays. We'll get into hashes later. So for today, for today, when I say collection, I mean an array. Okay, I'm going to use array and collection probably interchangeably. Today, we are only going to be working with arrays. All right, cool. Okay, great. Now that we've got that, so if I wanted to redo this like putsing of my characters using each, the way that it would look is, let's see, I'm going to comment this out for now. And actually, I'm going to just grab this. So I've got my characters. And if instead of putsing every single one individually, hard coding the index, if I wanted to use each, what I would do is I would say, hey, characters, call the each method. And then the syntax for each looks a little bit different than the methods that you learned about yesterday. So yesterday we talked about methods taking an argument. So an argument would be something in here. Each is a slightly different type of method. And instead of an argument, it takes what's called a block. So this block looks like this. I'm going to type this out and then I'm going to explain what's happening here. We start the block with do. We give it a pipe. We give it a thing right here. I'll talk about what that thing is called in just a second. And then we give it an end. So this is the basic syntax for each. Keep my notes in line here. Everything inside the do and end is called the block. So from the do to the end, this is called a block. Okay. Inside this block, we have a thing here. Right now it's character. And this is referred to as the block variable. So the thing inside the pipes, these vertical lines are called pipes. I'll just mark that out like that, is called the block variable. Move this over a little bit. So this is called the block variable. Okay, so now that we've got a little bit of vocab laid out here, let me talk through what is going to happen with this each thing. So what each does when you call it on a collection, in this case an array, it is going to do something to each of the elements inside of the array. And it's going to do that something to each of the elements in their indexed order. So it's, when I call this each, I'm saying, hey, characters, I want something to happen with each of the elements inside of your array, inside of this collection. Doesn't matter how many there are. There could be 3, there could be 3 million, there could be 0, there could be 10. Doesn't matter how many there are. Each is going to do something to each of them. And the thing that it's going to do is whatever code is in here. So this is where, actually, you know what I'm going to do. So what we want to do with each of these elements is puts it to the terminal. So we're going to try not to use the word put too much. We're going to place the code that we want to run on each element inside the block. So I want to puts, and I want to puts each of these characters. So I need a way to reference the element itself. And that the way that I reference the element itself is with this block variable. So when I created my block with each do, I created a block variable that I will use inside the block to reference each individual element. So I want to go through and put each character. Okay, I'm going to pause here for a second and just let you think about this just for a second. Okay, any questions about this so far? Yeah, Ben, go for it.
Just wondering if there is a specific naming convention that people should adhere to when creating that block variable. If there's like a kind of a standard for that.
Yeah, the standard is a collection is named in the plural, and the block variable is the singular of that collection. So in this case, my collection is called characters, and so the singular version of characters is character. So I have a collection of characters, and as I go through each one, I'm going to be holding on to a single character. So if this were like people, then this would be person. If this were dogs, this would be dog. Now, this is a convention or like an agreed upon style choice. This is not a hard and fast rule. I could name this block variable anything that I want. So I could have characters.each do and then name this friend, and this will work. So the convention, the like best practice is to name this block variable the singular of the collection. So character. Oops. I can put that here in my notes. Name the block. Let's see. Convention is to name the block the singular version of the collection name. Other questions so far? All right, cool. Okay, great. And I just ran it and showed that, yep, that did the thing. So that's good. I want to just like harp on, oh yeah, Olivia, did you have a question?
Why didn't you have to change friend back? Like where you puts friend?
Great question.
I was just curious like why it still worked or.
It does not work. If I
Okay.
run this, it will say undefined local variable or method friend, because
Okay.
when I changed this back, I forgot to change the actual block code. Thank you for calling me out on that. So yeah, so because I've named my block variable character, friend is not a thing that exists any longer. So I need to refer to it as character. And now this will work. Yeah, great question, Olivia. Got to keep me honest. All right, cool. So what each is doing here is it's going through each element, and there is a more technical term for this idea of going through each element, and that term is iteration. So iteration is the process of working through a collection element by element. Okay, so as we each over these characters, we are basically like looping through this block for as many times as we have characters. Whatever our number of characters is, that's how many times we're going to go through this block of code. So when this runs, it's going to go through once where our character is Phoebe. Then it's going to go through again where our character is Rachel. And then it's going to go through again where our character is Joey. Okay. And we can actually see this in action by putting a pry inside of our block. So I do my pries a little bit differently than Mike. I actually require pry up at the top of my files typically. And then in my block, I'll just put a binding.pry. Just another way of doing it. Either way works just fine. You can either require and bind on one line, or require at the top and bind wherever you want. So we can see this sort of iteration happening now by running our file. And you can see I've entered this pry session here on line 24. And if I take a look at what my character is, I've got Phoebe. Now we're going to talk more about pry later, but just a preview into what's coming. If you're in a pry session and you want to continue on running your code, so to continue on running your code, if you type in exit, which I know doesn't make a ton of sense, but just go with me on this. If you type in exit, it will continue running your code. And in this case, that means that I will hit the next iteration of my each. And now my character is Rachel. And if I exit to continue, my character is now Joey. Okay. Cool. Can I get, I'll sometimes do this, you may or may not have seen this before, but I like to sort of gauge how folks are doing using a fist to 5. Meaning a fist is like, I have no idea what's going on, Megan. Like, this is terrifying. And a 5 is, I feel like I could explain this to another human being. So can I get like a physical, like fist to 5? How are we feeling about each so far? And if you're like at a 0 or a 1, that's okay. Okay, I'm seeing some 3s, seeing some 4s, seeing some 5s, 3.5s. Like it. Okay, cool. We are going to continue on. Let's see, it's 11:29. Let me look at my notes here. Yeah, I think let's go ahead. I think it's a good moment to take a palm. So let's take a break and I will start back up at 11:35. So be back at 11:35.
Can I ask a quick question?
I would
Megan?
prefer if you wait until we come back from our palm to ask a question, just so that everyone has a chance to hear the question.
Oh, I just wanted you to scroll up on your each playground.rb real quick if you could. Sorry.
Oh, yes, that I can do.
Sweet. Thank you.
All right, we'll get started in about 20 seconds. Okay, cool. So before the POM, we went through the syntax for each. I saw in the chat that there were a few like comments and questions maybe about pry. We are going to go more over pry later, I promise. But a couple things that might be useful to know now is I've been sort of exiting to continue with just the keyword exit. If you ever need to just jump out of a pry session, regardless of where you are in your code, you can do it in two ways, at least two ways that I can think of off the top of my head. You can type exit bang, that exclamation point we refer to as bang, and that will get you like just totally out of it regardless of where you are. Or you can type triple bang and that will get you out as well. So just a side note on that. All right, cool. So let's go ahead and talk. Oh yeah, Regina, did you have a question?
So is it the same thing? I was like looking up pry last night and it had me do exit program. Although I guess I was using it in the terminal rather than in the text editor.
Yeah, I don't know off the top of my head. I'm not familiar with that command, so I'm not going to make any firm statements about it. I would say that's a great thing to research if you want. And if you're like still confused about it or want to post something in Slack, that would be great.
Okay. Yeah. Okay. Thank you.
Thanks. All right, cool. So let's talk now about like why would we want to do this? Like why each? Like why are we learning about this thing? So far we've used each to print something to the terminal, which is great, but maybe not something that you'll do all the time or really all that frequently. So each is really meant to solve a variety of problems. Anytime you need to do something with every element in a collection, each is a way to accomplish that, or iteration in general is a way to accomplish that. And each is one of the most powerful tools in our tool belt to accomplish the problem of, I need to do a thing with every element. How do I do that thing? So each solves the problem of, I need to do X with every element in this collection. And this, like, whatever we're doing with it, this thing that I need to do with every element generally falls into one of three categories. Sometimes we'll need to transform. Wow, I cannot type today. Transform. Sometimes we'll need to transform each element into something else. So like, let's say, well, we'll go into some examples of this, but let's say we have a collection of numbers and we want to get all of those numbers doubled. We need to transform each element of the collection. So like we need to change, or you'll often hear this called like mutate, every element in a collection. So we might need to change, or we might need to transform some things. One of the other like big three uses for each or iteration is to get a subset. And a subset would be like if we have 100 names and we want to get all the names that are like fewer than 3 characters, for example, we want to find a subset of the larger collection. So I want to get one or a small set of the total collection. And then the last thing is we want to create something totally new. I want to use the collection to create something completely new. And I think the most like easily digestible example of this is to sum a collection of numbers. And we're going to walk through each of these and have an example of each. Sorry, I keep using each. We're going to walk through these 3 types of problems that you might come up against when working with a collection and look at an example of them using each. All right, cool. So like I said, when we have a collection of elements, we often need to do one of these 3 things with it. Transform all of the elements into something else, or give them some new attribute or something like that. We need to get a subset. So take a collection and find like 1 or a smaller number of that collection, or create something totally new. Okay, and we're going to talk through these now. So let's start with transform. So let's transform. Wow, I cannot type. Sorry, unlike Mike, I do talk while I'm typing, so apologies if that's very annoying, but I don't know if I can stop. All right, so let's work on this transform piece. So I'm gonna go down. I'm trying to keep my notes lined up here so that it's hopefully a little bit easier to read, but maybe it's very confusing. I don't know. Okay, so we're talking about transformation. So let's say that we have a collection of names. So I'm going to say names equals, let's do Mike, Bob, and I think I saw Sal lurking in here. So we'll put Sal in here as well. And I'm going to comment out our characters from above just so that we don't get too confused with what's happening in here. So we've got our names, Mike, Bob, and Sal. And what I want to do is return an array of the names capitalized. So I've got Mike, Bob, and Sal all lowercase. What I want is an array of Mike, Bob, and Sal capitalized, so the first letter capitalized. So what I might do here, actually, you know what? Let's take a minute. I'd like for each of you to think through, like, how might you figure this out using each based on what you know now. So let's take just a minute to do some independent thinking on this. And in 10 seconds, I'm going to ask if any brave soul wants to volunteer to walk me through this. All right, does anyone feel like they have an idea of even how to start this? Let's go with Andrew. I don't think I've heard from Andrew today yet.
Cool. So you would want to do like names.each.
Great.
And
so
then
we want to call each on our collection names.
And then the block variable would be name, singular.
Like
in
this?
the pipes.
In pipes, great.
Yeah.
Yeah, you have to be very specific with me.
No worries. And then on the next line, we would put name dot upcase. Or
I'm
we,
going to change this actually to name.capitalize. I just want the first letter to be
oh,
capitalized.
okay. No worries.
But
Cool.
upcase is also a very useful method.
Cool.
But nope, not capitalized. There we go.
Cool. And then on the next line, we put end.
Great. All right, cool. And then just so that we can see kind of what is happening in here, what should I maybe try and puts to my terminal?
Oh, me?
Yeah, sorry, I forgot who was just talking. I'm so sorry.
No, it's all good.
Yeah, what's something I could try and puts to my terminal to see these names capitalized?
Oh, puts names.
Cool. Let's try it out. All right, great. Let's go ahead and run this. All right, so what I'm getting here is Mike, Bob, and Sal, but they're not capitalized. So this is an interesting piece of each that we haven't talked about yet. And that is the return value of this method. Genevieve, did you have a question or a comment?
Yeah, so if you do the puts within the block of code, then it will, so you would have to do, yeah, puts name dot capitalized, then it would run.
So that works in the sense that it does puts each name capitalized, but what if I want to use that collection later? Is there a way that I can like use the whole collection of capitalized names later? The way that it is now, there's not really. Chris, did you have a question or a comment?
I was just going to go over how to take a guess at how to do it, but
Oh, go for it.
We would have to make a new array with a new variable name.
Why?
Because each is only returning the old array.
Cool.
So.
Awesome. Yeah, I want to go back to my syntax here, and I'm just going to make this like, this is just a special note. Special note. Each, the method each. Oh, that's not what I wanted. Sorry, relearning Markdown. Each returns the original array. I want everyone to write this down somewhere, like physically write this down. Each returns the original array. Great. Each returns the original array. Okay. All right. So remember yesterday, Mike was talking about how every method has a return value. The return value of each is always going to be the original array. So when we use each to do something like transform or find a subset of or create something new, what we want to do is create a place where we can store the result of what we do in the iteration. So we need a placeholder to store what happens in while each is iterating over the collection. So just like Chris said, what we're going to need to do is create a new array that's going to hold our capitalized names as we iterate over our lowercase names. So the way that this is going to look is I'm going to create a capital names variable, and I'm going to create an array, an empty array, that's going to be the starting point for our new array that we're going to use each to create. So as I iterate over each name, I want to put the capitalized version of that name into my placeholder array. Sometimes this placeholder array is called an accumulator. Accumulator. A placeholder. So you'll hear accumulator. calculator. I can type. So you'll hear that word sometimes. If you look at the lesson plan, you'll see this word in there. So as I iterate over the names, I'm going to want to shovel that capitalized name into my capital names array. So as I iterate, I'm capitalizing the name and putting it into my placeholder array. So now let's go back to Genevieve. Now, Genevieve, what do I want to put here to see my capital names, my capitalized names?
So you would do puts capital names.
Great. Yep. Puts capital names. And now I'm putting that array. Now, puts does some funny things to arrays. What I might use here instead is P, which actually shows me the whole array without like making any pretty changes to it. So just another way of like printing something to the terminal using P instead. Cool. Any questions about this transforming names, storing them in an accumulator, return values of each? Any questions so far? All right. Cool. Let's move on and let's get a subset of something. So for now, I'm going to go ahead and just comment out our transform. And let's try and get a subset. Oh, Joseph, did you have a question?
I answered my own question. I was mostly asking if you would call an empty hash an accumulator as well.
Yes, in this case, I would. I mean, not every empty hash is going to be an accumulator. Sometimes an empty hash is just an empty hash. But in this process of using each to solve this problem,
yeah,
an empty hash would be an accumulator.
Perfect. Thanks.
Yeah. Also, if anyone has a preferred name that I don't use or haven't heard before, feel free to just correct me. I'm okay with that. I want to call you what you want to be called. All right. Sweet. Yes. Okay. We're getting a subset. So let's say we have an array of numbers. I'm just going to copy this from the lesson because typing is not my friend right now. So let's say we have an array of numbers and we want to return an array of all the even numbers. So let's do the minute of independent thought again here. So I want to return an array of all of the even numbers. I'll give y'all a minute to think about how you might do this using each. Yeah, let's take just about 5 more seconds. All right, does anyone think they have an idea of how to start this or how to accomplish this? Trevor.
I think it would be, you create a new array called even, like an empty array.
Cool.
And then it would be numbers.each do number in pipes, And then I did it as an if statement with if number dot even equals true. Puts, or sorry, shovel number into even. And then end.
Do I need another end?
Yes, sorry.
Great. That's okay.
Double end.
Yep. Got to end our if and end our block. And then does this even method take a question mark? Does anyone know?
Can't remember.
offhand?
That's what I was about to look up, and I forgot to do that.
No worries. I'm just gonna say yes, it does.
Cool. Thank you.
Great. Cool. And then Trevor, what do I want to print to the terminal to see all of my even numbers?
P even.
Great. All right, let's run it. Cool. That looks good. Awesome. We've got a couple of hands up. Let's go Ben and then Katie.
In this instance, I'm not sure that we even need the equals equals true. Is that correct?
That is correct. That is correct. So yeah, so this is what I'm going to do. This line will work, or we could substitute if number dot even. So either of these will work, and I will let you all experiment and play with that on your own. Katie, did you have a question?
You don't even, oh, sorry.
No, that was actually what I was just going to say too.
Okay, cool. Who did I just interrupt? I apologize.
Would you need the if still as well?
Yes. All right. Any other questions about this subset piece? So we're saying we want to shovel in that element if it meets a certain criteria. All right. Cool. Let's go on to creating something new. And I see that I'm running late on time. So oops, oh no, I didn't mean to just delete that. So I am going to just do this one on my own. So we're going to create something new. And what I said here, like the most easily digestible example, I think, is like a sum of a collection of numbers. So that's what I'm going to do here. So I'm going to take my numbers array again. Where am I? Here I am. And I want to sum all numbers in the array. And so again, I'm going to need an accumulator, and I'm going to call this sum. And in this case, my accumulator is not going to be an empty array. It's going to be the starting place for this addition of, like, I'm adding 1, and then I'm adding 2, and then I'm adding 3, and then I'm adding 4, and then I'm adding 5. So typically when we do these like math things, the starting point is not an empty array, but 0. I'm going to start my sum at 0, and I'm going to continue adding numbers to it. And I'm going to do that with each. I'm going to say numbers.each do, and we'll call this number. And I want to increment my sum by whatever number I am on in my iteration. So I'm going to say sum plus equals number. And then I can print my sum, and hopefully this math is correct, 55. I'm going to trust Ruby that that is correct. I'm not very good at math. Just a note here on this, like sum plus equals, you may have seen this syntax before, but another way of doing that is to say sum equals the sum plus the number that I'm on. So these two statements are equivalent. So this will also give me 55. But when you accumulate things or when you increment things like this, you will more often see the syntax sum plus equals. So this is like adding and resetting the value of sum. Questions on this one? Okay. Can I get a fist of 5 of how you're feeling about each at this point? And still a 1 or a 0 is okay. Okay, I'm seeing like lots of fingers. I like that. Okay, great. There's one other thing that I want to show you, and then I will let you go for lunch. And that is that there is another syntax for each. And so I'm going to go back up to my syntax here. Let me comment out my numbers. I'm going to go back up to the syntax. And there is, so this is like what I would consider a multi-line syntax. So this first one is, this is multi-line, multi-line. And there is also a single line syntax, which looks like this. Oops, doesn't look like that, looks like this. Okay, so the difference between these two syntaxes, coming out of that pry, is that instead of using do and end to encase my block, I'm using curly brackets, curly braces, curly brackets. So instead of do and end, you can use curly braces and put everything all on one line. You still need your block variable. You still need to do something in that block, but you can replace do and end with curly braces. I personally, this is a personal preference. I personally prefer multi-line syntax. I think that it is easier to read, but that is just a Megan thing. If you all like the single line syntax, it's just as good. So you can use whichever you prefer. Did we have some questions? I thought I saw maybe Kwa and yeah, Kwa, did you have a question?
Yeah, so that single line syntax is, I can't turn that into a multi-line, right? No matter what, I have to keep it on one line, no matter how long the definition of the method is. So like if I put character and then I keep on pressing enter going down and the curly bracket is at the bottom, that shouldn't work, correct?
I actually think it might work. Yeah, it does.
Okay.
But it's sort of like, it's not very Ruby. It's not very Ruby friendly. This is the sort of thing that if you do this and another Ruby developer looks at it, they're going to be like, why did you make this choice? That's a weird thing to do.
Okay.
It works, but you won't see it in the wild.
So
if you use the curly braces, you'll see it all on one line.
Okay. So I mean, if it's like a sort method or like an add method, I'll use single line. Okay. Thank you.
Yeah, you could. The one thing that I'll say is like, okay, I'm going to say more than one thing. Ruby is a language that has a very strong community, and that community has some very strong style preferences, has some very strong conventions, I'll say. And so there are some things like this single line thing where if I put it on many lines, it works, but other Rubyists would be like, I don't get it. I don't understand why you're doing it that way. And I'll try and be pretty clear about like when it's a rule or a thing that will break Ruby and when it is just like very strong convention. The very strong convention that I will mention is if you like single line syntax, only use single line syntax. If you like multi-line, only use multi-line. The thing that makes a file look really jumbled, or one of the things that it can make a file look really jumbled, is if you mix up syntaxes unnecessarily. So if you use like, sometimes when you're doing a sum, you use a single line and sometimes multi-line, it can look a little bit messy. So try and stick with like one convention. I see Sal making a face. Sal, do you want to add something to that?
No, I was just thinking through, I was trying to think through like how I make that decision on whether to use the single line or the multi-line syntax. And I think that frequently it does have to do with like first of all, I'm with you, Megan. Like I just like the multi-line syntax, and that's frequently what I use. But I think sometimes some people will say if it's like simple, if it's like a one-line piece, like kind of like what you have here, where it's just like puts character, then they might prefer it on a single line. But the thing that I would say is if it's complex, I would say if it's complex, definitely put it on multi-lines. This is also an interesting, I start thinking about things like style guides and stuff like this. And basically like, just to give you all in Mod 1 an idea, there are, people take this kind of thing seriously enough that there are like, I don't know, I think it's like 100-page long style guides about like how Ruby should be written at a particular company. And one of the, yeah, Bob, Nerd Wars sounds about right. I'd be intrigued actually to hear what Bob Gu has to say. But like Airbnb, for example, has like this really very detailed Ruby style guide. And to me, the most important thing is being flexible enough that when you join a team, that you all can write code in a way that when you're looking at someone else's code, it's not surprising to you, and you can kind of like parse it without having like without having to think about it a ton. And when somebody else looks at your code, they can kind of do the same thing, right? You want to be able to step in and out of it and not have to waste. Programming is hard enough. You don't have to waste your brain power on like just trying to even understand what someone is doing.
Andrew, did you have a question?
Yeah, it was kind of about that. So like on the subset section where we did the numbers and wanted all the even numbers, like putting that if into a single line, like Sal said, would be a little more difficult and more confusing. So we want to do multi-line for that.
Yep, for sure.
But you could do it on single line if you wanted. It would just look like a mess.
You could. You know, there's one thing that y'all could look into that might be interesting is there are many ways of writing if statements, and there are ways to write them on a single line. So that might be a fun research project in your spare time.
Cool, thank you.
Cool. All right. Other questions about the single line syntax or anything else that we've covered today? As you think about what questions you might have, I'm going to pull the lesson that I've been working from down onto this thing. At the bottom here is some practice. We don't have time to go through this practice now because we are plus 8 minutes on our time. But this would be good practice to like get together with a buddy over lunch or this evening and work through some of these examples. And if you have questions on them, definitely reach out to me. I'm happy to answer questions on any of these. Any last questions before I let you go? Okay, I think Robbie would be excited about that amount of dead air. So I will let you go. Have a good lunch. This afternoon, what do you have? You have something this afternoon. I believe you have a lesson with Bob. It's going to be great. All right. I will post this video on YouTube when it is ready, and I'll see y'all later. Thanks, everyone.
Thanks, Megan.
Thank you.
Thanks.